I invite next and last speaker of the session, Dr. Pandian. Dr. Pandian is our colleague working in CCA as Scientist D. He has multiple papers on IoT and PKI. He is PhD from IIT Patna and a postdoc from New York University.
A warm welcome to all the participants. I hope I am the one and only speaker in physical mode. I don't want to bore you much also before the big lunch organized by CDAC. This is one of my research area where an efficient hyperchaotic key generation sequence using the Perturbance process for an PKI applications. Basically, the main idea of Kirchhoff's principle is make your key strong rather than the key algorithm. So that's what the main motive behind in organizing such an keystream sequences and getting into an hyperchaotic system so that my system gets stronger more than the key algorithm. Moreover, if I want to go for an asymmetric key or symmetric key concept, asymmetric is basically the system management or the perturbation process. So in order to kill that process during this quantum computing, so it's better to focus more towards the key generation sequence where I need to make my system more strong in that attitude of symmetric key. So let me get into the outline. So I'll be giving a brief gist of what is the cryptography, what is the dimension of cryptography, how my hardware and software security going to play a major role, and what is the public, how it's going to integrate. Basically, that's what my cup of tea, where I have to integrate my symmetric key concept with the asymmetric, and how I have to enhance my lightweight cryptography for the PKI industry. So what are the research gaps? What are the motivation behind and objective of this research area which I have focused on? And what are the proposed methodology and algorithm we have developed with the research outcome and the discussions. So what is basically cryptography? It's basically information security while transmitting. I have to make my link application within intact with the information, either in terms of military, government data, or document online transactions, anywhere where the e-trade secrets, e-commerce. So these are the different areas where I want to make my information security more stronger. So this topic would be much in deep to the technical aspects. Moreover, we can able to understand the reason behind the prerequisite about the cryptography. Moreover, the network and communications mainly lies on the cryptographic measures to protect the data during the transmission. This is the main idea where the cryptography is going to play a major role in the PKI industry, where I want to make the key concept, basically the digital signature big concept, to be strong enough. So what is the cryptography? It's basically the study to protect the data for the confidentiality, integrity, and availability. What do you mean by confidential? I have to hide the information from unauthorized access. I have to prevent the information from unauthorized modification. I have to make available to all the information access to the user, the defined user. So this is the main way the cryptography is going to play a major role in terms of hardware security as well as the software security is concerned. When I'm talking about the product, where the physical security is most important, where I have to concentrate on the confidentiality as well as integrity. When I'm talking about the organization security, I have to concentrate on the availability and the integrity. When I'm talking about this, the people have to talk about this confidentiality and availability. So these are the three goals of the cryptography, where I have to make my identity specific for the information security to be intact while transmitting any data. So what are the dimensions? So we are like the couple of three dimensions are there. Basically, we have been segregating it. The type of operation we are going to execute in terms of data transmission for substituting or transportation, or the product method used for plain text and the ciphertext. So the way in which the either the way in which the number of keys are used, whether it's in symmetric mode or asymmetric mode. So that's what the main industrial activity has been happening with the PKI concept, where the asymmetric keys are used, whereas the RSA is used. Recently, the ECC curves are coming up with the ECC modes of PKI industries. The main advantage of asymmetric is like basically it's a lightweight, not too heavy to understand. But it's when the quantum computing comes, all the asymmetric concept is going to be nullified. So in that angle, the symmetric is going to take up the next goal in the public key infrastructures. So this is the way where the key symmetric and asymmetric concept is going to play a major role for the key exchange mode. So when I'm talking about the symmetric, it's used for the communication. When I'm talking about the public key, it's used for exchanging the symmetric keys. And most the digital signature are going to play a valid role for this public keys. So when I'm talking about the digital signature, so how the digital signature is executed with reference to my asymmetric key. Either I have to transmit my data as a private key or public key. So in what way I have to exchange the data. So this is the main industrial factors where this dimension of cryptography playing a major role. And that's what the system, security of the system must also rely on the security of the key, not on the security of the algorithm. So that's what asymmetric key, it does only key management, does not produce any key factor. So symmetric key does a key generation. So when you do for a key generation sequence, then you can able to identify how keys are secured. So those things can be integrated along with your PKI applications that makes your strong generation, that makes your identity to save your privacy and the confidentiality. Let me give a brief idea what is hardware and software security basically. So when I'm talking about the software hardware security cryptography, so it's basically the performed on the software-based platform. It's based on the hardware-based platform, basically FPGA or ASIC design. So there are many advantages on both the areas where the software cryptography comes into play, where it can be used in any OS, general OS operating systems, and we can have a multiple platform, multiple application on single platforms, and it can be used for the block ciphers. But if you compare to the hardware cryptography, you cannot use for block cipher, it's mainly used for the stream cipher, because I have to take bit by bit of information from my hardware device, then I can encrypt. But the encrypting the sequence on the whole, the model will make my identity to be more secure. That's what the disadvantage of the software secure cryptography does, because you can run any malicious code on any platform that will kill your kernel. But when I'm talking about the hardware security, you won't be able to kill your kernel because it is hardware defined identity, so that any design, any ASIC design with the key impact into the design cannot be used. So this is the reason where hardware cryptography is going to play a major role in the PKI applications also in future coming up. So along with this symmetric key concept. So what is a public key infrastructure and how the public key security is going to play a major role? So when I'm talking about the service, the privacy, authentication, integrity and non-repeatability. So this is my service. For this service, what I have to do? I have to apply my technology, that is public key technology. For this technology, I have to deploy the infrastructure, that is digital creations of certificate, digital certificate activation, security management. So these are the infrastructures where integrated along with the application service to enhance my activity. So for the service, either you go for a symmetric or asymmetric, but ultimately I have to fulfill the service which is required for the digital signature to enhance the PK application. So PK infrastructure, it has a set of hardwares where it has to enhance the problem to be identified in order to make improve the message transmission to any mode of communication, as well as I have to make my certifying authorities, as well as I have to send a trusted certificate to any mode of channel with reference to the key generated. So this certificate, which is very much useful to make my identity cleared with the digital signature, so that any mode of transmission will not lose my data in any transactions. So what are the research gaps? Still now it has been identified is most of the key generation or key sequence, that is a non-linearity in this activity of key generation sequence in the feedback shift mode registers. And there is correlation immunity in order to make the algorithm resist to attack. So these are the major areas where it has to be identified in the feedback functions. It has to be filled up to enhance the activity to more stronger key strength. So this key strength will improve my quality of my key stream sequence, and this will go for a recursive pseudo-random binary sequence using a feedback function in the linearity mode, and it will enhance my non-linearity so that it can improve my sequence structure, cannot be predicted by any end user. So as a researcher, addressing the empirical approach to minimize the gate complexity, that is the one more channel. I do not want to make my keystream sequence too heavy. It should be a lightweight cryptography also. It has to increase my strength also, as well it has to identify non-linearity, as well as the correlation immunity. It has to be improved in all the way of sequence. It will fulfill all my gaps. So when the sequence is addressed, so these research gaps will be able to identify my dynamic key value so that I can increase the strength of the key correlation sequence in a multiple sequence of a doubled manner. Otherwise, any key sequence with the normal sequence can be able to be predicted by the pseudo-random generator or any brute force attacks or any other attacks. So this is a way where the research gaps are very much important in activating this nonlinearity in the sequence. So what are the motivations basically towards the hardware-based cryptography? Basically this secured key generation, keystream for larger length with a minimal number of stages, low logic complexity for nonlinear Boolean functions, and low hardware complexity and high throughput. So these are the main motives and main motive to improve towards the hardware cryptography. And basically this hardware cryptography can be utilized for the generation of the sequence in a non-recursive mode. Basically, see all the normal feedback switches with a recursive mode. So the main motive to create a non-linearity in the sequence to improve the gaps. So objective of this proposal to be develop an efficient algorithm architecture to generate the larger sequence so that it can improve or secure the privacy information with a low hardware complexity and high throughput. It means I can minimize the hardware, I can improve the speed. The quality of speed of the sequence can be improved. So we have developed an architecture efficient also using the non-Boolean Boolean function technique with the minimum logic complexity, and a new crypto system has been defined to meet the demand of integrity and confidentiality in the privacy information, and the hardware has been implemented with the high throughput. So this I have integrated with the FPGA device. So this is the overall the proposed methodology I have integrated. So if we talk about this the chaotic functions, so this chaotic function will be giving my perturbation process, where this perturbation process will give me my input towards a nonlinear Boolean function. So that is going to decide my number of stages. So that will decide my size of my pseudorandom sequence. So because of this process, I'll be considering as a one-way public key function that has been integrated with this public key, and it will generate a dynamic key. See this overall procedure during the transmission, which is going to happen at the one end of the user, we can say Bob and Alice. So the dynamic key stream can be encrypted. So this is one part. When I'm going to transmit my analog signal, I can use this ADC DAC. Otherwise, I'll be giving my dynamic key stream with a normal digital signal. It can be encrypted and it can be transmitted over the wireless or wired mode through the network media. See, this overall procedure of proposed methodology can be utilized in a different angle with the public key with a digital signature concept, so that we can able to segregate the asymmetric key methodology. It can be integrated with the symmetric concept, and moreover this can be integrated in a separate chip so that it can be integrated for the hardware HSO model as well, because I need to secure my data with some mode of encryption. So this is the way I'm going to encrypt my data with a more secure long generation sequence. So with this proposed methodology, I have developed an algorithm which is using the hyperchaotic systems, where the system is going to have 4 different types of equations, where this equation will improve my lot of confusion, because I need a more confused state of sequence, and this sequence can be integrated using this self-syncing generator. This generator will give me a normal sequence where the sequence can be integrated along with this key generator as well as the key strength, improve my key strength. So apart from this, when I'm moving that equations from the SSL, that is a self-syncing generator, it is moved towards a hyperchaotic system. This hyperchaotic system can be utilized for the Lyapunov exponents. This Lyapunov exponent should have minimum, it should have a positive value. When the positive value is more than the 0.1, it means it has understood there is a lot of confusion in this key generation sequence that can integrate my value of key strength. Finally, discretion process. This will give you my perturbation process, where it will take up the zeros and ones, because this discretion process will determine how difficult it is to generate, because you cannot predict what is going to happen in future coming up in the long number of stages, because it's not like a 2 per like a n bit. I'll be getting a 2 per n minus 1 sequence. So you cannot able to, because it is a continuous process. It's not a pseudo random sequence. It's a true random sequence. See, this true random sequence, again, it is perturbated by the discretion process in terms of producing my longer sequence in the strength. Finally, let's come to the results in the discussion. So the proposed Lyapunov exponents will have the beta 2.94 lambda 1 and minus 15 lambda 4. So this is, see, compared to the other hyperchaotic systems, so this, the lambda 1 has the better value which is proposed in the sequence. So it's giving my better brute force attack analysis as well as in terms of larger stages of value. And almost all the statistical analysis, the NIST test which I proposed it, which is clearing this sequence strength. Because we have taken more than 50,000 samples of data for executing this test process. Finally, the proposed generator can be utilized in any PK application mode where it can be able to integrate with your system design. And this system design can be integrated along with this proposed Lipno exponents value to existing chaotic systems. Chaotic system basically gives a confused state of information, and this can be executed with against cryptanalytic attacks. So these different mode of applications along with your design structure, along with these hypocritic systems in a symmetric mode, will enhance my sequence as well as strengthen my PK applications. So with this, I'll conclude my presentation.
Thank you, Dr. Pandian.